All right, so now we'll start with problem number 1, where it says here convert 540 degrees to radian measure. Okay. And here we're converting from degrees to radians, so that means we multiply by pi radians over 180 degrees. So the way we set that problem up would be to do this. We have 540 degrees, so we're going to use that ratio of pi radians over 180 degrees. All right. Now you're going to see that the degree symbol divides out. So here you're going to have like 540 over 1 times pi. That would be 540 pi radians over 180. And then you'll do 540 divided by 180, which is 3. So I have 3 pi, and it'll be 3 pi radians. Okay. And you do need to put the unit there of radians because you're converting from degrees to radians. Okay. Are there any questions about problem number 1? All right, number 2 is converting 11 pi over 10 radians to degree measure. So we have 11 pi over 10, and of course this is in radians. We're converting that to degree measure. So in this case here, we're going from radians to degrees, so that means we're going to multiply by this ratio, 180 degrees over pi radians. Okay, so this is going to be 180 degrees over pi radians. And then that's equal to, now the radians divide out. So you'll have, and also pi divides out as well. So you have 11 times 180 divided by 10. Now go ahead and write that out. 11 times 180 degrees divided by 10. So what's 11 times 180 divided by 10?
1980.
Not 1980. 198. So it's 198 degrees.
Oh, I'm sorry.
Okay.
I thought she was going to step by step.
Okay. Because if you did it like this, 11 times 180 divided by 10, 198. You can do all that in one step.
Okay.
All right. Any other questions? Okay. Problem number 3. And here we got A, B, and C. We're going to evaluate the following using a unit circle and give the exact value. So in part A, we got the cosine of 5 pi over 3. Cosine of 5 pi over 3. So here we can use that regular unit circle with all the degrees on it and find 5 pi over 3. It'd be 1/2 because the x-coordinate, keep in mind, is always going to be the cosine. The y-coordinate would be the sine. So in this case here, 5 pi over 3, and you find its cosine, it will be 1/2. So the cosine of 5 pi over 3 is 1/2. Okay. All right, any questions about part A? Now, part B, we got the tangent of negative 3 pi over 4.
Add 2 pi.
Yeah, add 2 pi, and that would help you get a positive angle for that. All right, so now, if I take that negative 3 pi fourths, add 2 pi to it, this will end up, well, this will be the tangent of, let's see here, if I do negative 3 fourths plus 2 and then do the math key in number 1 for fraction, this will be 5 pi over 4. Now, if you recall that the tangent, the identity for the tangent is always going to be, in this case, sine over cosine. Tangent is always sine over the cosine, so this will be sine of 5 pi fourths divided by the tangent of 5 pi fourths. And then using that unit circle, what will be the sine of 5 pi over 4?
Negative square root of 2 over 2.
Right, negative square root of 2 over 2. And then what about for, and this should be cosine for the denominator. That's sine over the cosine. I don't know why I get that. So sine of 5 pi over 4, that's negative square root of 2 over 2, over what would be the cosine of 5 pi over 4? Also negative square root of 2 over 2. Well, if I divide the negative square root of 2 over 2 by itself, it will end up being 1. So the tangent of negative 3 pi fourths will be 1. Okay. All right, questions about part B. All right, part C, we got the sine of negative pi thirds. Add 2 pi, because it's a negative angle. So I know I'm going to have the sine of, let's see, negative 1 divided by 3 plus 2, math key, and then number 1 for fraction. This will be 5 thirds, but it's going to be 5 pi over 3. And on the unit circle, 5 pi over 3, which is here, the sine is going to be what?
Negative square root of 3 over 2.
Negative square root of 3 over 2. All right. All right. Are there any questions about problem number 3? Okay. All right, problem number 4. You're given the cosine of theta is equal to negative 4/5, and theta is an angle in quadrant 2. Find the exact value of the remaining trigonometric functions of theta. Okay. So we're told in problem number 4 that cosine of theta is equal to negative 4/5. The angle is in quadrant 2. So sometimes it does help to draw a picture what that angle looks like. So I'm going to draw my coordinate plane. And the angle is in quadrant 2, so that means here's quadrant 2 right here. I'm going to go ahead and draw the hypotenuse here. And the angle that's going to be perpendicular to my x-axis. So here's theta. Cosine is always going to be the adjacent side over the hypotenuse. Okay? Cosine is adjacent over hypotenuse. So here, that 4 is going to be negative. Because it's in the second quadrant, that means my x-coordinate has to be negative. The hypotenuse here is 5. That's the longest side. Okay, so this is going to be x. That's going to be r right there. Y is what I need to find out before I can get my other trig functions here. So here we use this, x squared plus y squared is equal to r squared. That's the Pythagorean theorem using x and y and r. So here my x is the -4. So it'd be -4 and that's squared. Plus y is what I'm trying to find. So I have y squared is equal to r. That's going to be 5. And that's squared. -4 squared would be 16. Plus y squared is equal to 5 squared, which is 25. And then to get y squared by itself, we subtract 16. So it'd be y squared is equal to 9. And then to find out what y, the opposite of squaring something, would be to square root both sides. So it'd be y is equal to 3. And it's going to be positive 3 since it's in the second quadrant. And in the second quadrant, the x-coordinate is negative, the y-coordinate will be positive. Okay, so now I can go ahead and find what the sine of theta is. I know what the cosine of theta is. That's -4/5. And then the tangent of theta, that's where we use those these identities here, these properties here. So the sine is going to be the opposite over the hypotenuse. So what will be the sine of theta be equal to? Opposite is 3 and hypotenuse is 5. So it's 3/5. Cosine of theta we already have, but for the tangent of theta, it will be the opposite over adjacent. So this would be 3 over -4. Now, once I have sine, cosine, and tangent, I can find their reciprocals. The cosecant, the secant, and the cotangent of theta. So in this case, for the cosecant of theta, it's the reciprocal of the sine. So what's the reciprocal of 3/5? 5 over 3. And then the secant is the reciprocal of the cosine. So what's the reciprocal of -4/5? -5 over 4. And then for the tangent, well, the cotangent is the reciprocal of the tangent. So what's the reciprocal of 3 over -4? -4 over 3. Okay. Any questions about problem number 4?
Why do 5 be negative instead of 4?
It really doesn't matter.
Oh.
Okay. To be honest with you, really didn't matter here. All right. Any other questions? Okay, problem number 5. That's where you're going to use the sum or difference identity to find the exact value of the expression cosine of pi thirds plus pi fourths. Okay. In this case here, we have to use these sum and difference identities right here. And in this case, we're dealing with the cosine, so it's got to be one of these two right here. And we got the plus sign, so it narrows down to this one, cosine of alpha plus beta. And we write it like this: the cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. Okay. So in this case here, this will be the cosine of the first angle, which is pi thirds, times the cosine of the second angle, that's pi fourths. And then we do minus the sine of the first angle, that's pi thirds, sine of the second angle, pi fourths. Okay. All right, and then we can use that unit circle to help us find out what those values are going to be. For cosine of pi thirds is right here. The cosine would be what? 1/2. Times the cosine of pi fourths, that's going to be what? Square root of 2 over 2. Minus the sine of pi thirds would be what? Okay. And then times sine of pi fourths. Square root of 2 over 2. And then we just simplify this right here. Let's see here. We'll have to do numerator times numerator over denominator times denominator. So 1 times square root of 2 would just be the square root of 2 over 2 times 2, which is 4. And then minus, now the square root of 3 times the square root of 2. We can multiply underneath the square root symbols to get the square root of 6 over 2 times 2, which is 4. And since these denominators are the same, I can write the square root of 2 minus the square root of 6. All that is divided by 4. And I would go no further than that. So it'd be the square root of 2 minus the square root of 6, all divided by 4. Okay. Questions on problem number 5. Okay. And then number 6, you're going to find the exact value of the expression by using appropriate identities here. Here we got the sine of 73 degrees, cosine of 13 degrees, minus cosine of 73 degrees, sine of 13 degrees. So in this case, this will follow one of these. I know it's got to be either the cosine or the sine. It's going to be, yeah, it's going to be the third one. Because this is sine of alpha, so cosine of beta minus cosine of alpha, sine of beta. So it'll be sine of alpha minus beta. So this simplifies as the sine of the first angle, that's 73 degrees, minus the second angle, 13 degrees. And what's 73 degrees minus 13 degrees? 60 degrees. So using that unit table, the sine of 60 degrees would be, well, here's 60. What would be his sine? Square root of 3 over 2. Okay. All right. Are there any questions about problem number 6? Okay, problem number 7 looks like this. And this is a trigonometric equation that we're going to solve. We got 12 cosine square of x is equal to 3 on the interval from 0 to 2 pi. Let's see. And that interval should be 0 to 2 pi with a parentheses for pi, because 0 and 2 pi carry the same value for sine and the cosine. All right, so in this case here, we need to get cosine of x by itself. We're multiplying it by 12, so that means I need to divide both sides by 12. So that means cosine square of x will be, what's 3 over 12 in simplest form? 1/4. And then the opposite of squaring something would be to square root both sides. But if we take the square root on both sides, we need plus or minus. So now cosine of x will be by itself, and that's equal to plus or minus. The square root of 1 is just 1. The square root of 4 is 2. So I got cosine of x is equal to plus or minus 1/2. What that means here is this, that the cosine of x is equal to positive 1/2. Cosine of x is equal to negative 1/2. Now we're going to need all values of x, and they're going to be in terms of pi, where the cosine of x is equal to 1/2 and where cosine of x is equal to negative 1/2. So this is where we use that unit circle. And the cosine is always the x coordinate, so we need to find where 1/2 is our x coordinate, and that's right here and also down here. What would be my angle measures here? But what's the angle measure? This pi over 3. We're going to do this in terms of pi, since we're from 0 to 2 pi. That's pi thirds, and the other one, I do see 1/2 as 5 pi over 3. And then for negative 1/2, we need the x coordinate of negative 1/2 here on this unit circle. Well, here's one of them. What would be that angle measure for that? 2 pi over 3. The other one, 4 pi over 3. Yeah. All right. Are there any questions about problem number 7? Now in problem number 8, and there's A, B, and C, which is on the back of this page, we're going to evaluate the inverse sine of the negative square root of 2 over 2. So this is part A, inverse sine of negative square root of 2 over 2. What that simply means here is this. We need the angle measure where the sine of that angle is going to be negative square root of 2 over 2. Now, we're going to use the unit circle that has the inverse sine. And that's this one right here. What was that? Negative pi fourths. Okay. because here's negative square root of 2 over 2 for the y-coordinate, which represents the sine. The angle measured corresponding to that would be negative pi over 4. So that means theta is equal to negative pi over 4. Okay. Are there any questions about part A? All right, now part B is this. The inverse cosine of the cosine of negative 4 pi over 3. Now already, let's work on the inside. We already got a negative angle. So I need to add what to make it positive? 2 pi. So I'm going to bring over the inverse cosine of the cosine of, now we're going to add 2 pi to negative 4 pi thirds. So here I'm going to have the inverse cosine of the cosine of, let's see, negative 4 divided by 3 plus 2, math, number 1 for fraction. This ends up being 2 pi over 3. Now, let's use the regular unit circle to find the cosine of 2 pi over 3. Yeah, negative 1/2, because here's 2 pi thirds. The x-coordinate for the cosine is negative 1/2. So here, cosine of 2 pi thirds, I'm going to bring down this inverse cosine. That'd be negative 1/2. Now I'm going to go to the circle that says inverse cosine. Inverse cosine, which is this right here. Yeah. Negative 1/2 is here for the x-coordinate, and 2 pi thirds represents the angle where cosine of 2 pi thirds is negative 1/2. Okay. Are there any questions about part B? All right, now part C, which is on the back of this sheet. Here we got the cosine of inverse cosine of 3 square root of 3 over 2. Inverse cosine of square root of 3 over 2. That means I need the angle where the cosine of theta is equal to the square root of 3 over 2. So let's look at that, the circle that has inverse cosine, and find square root of 3 over 2 as the x-coordinate, which is what? Pi over 6. Okay. Are there any questions about problem number 8? All right, problem number 9 is this. Here we're going to draw a right triangle to simplify the expression of cosine of the inverse sine of 6x. So here we have the cosine of the inverse sine of 6x. Now this part right here, the inverse sine of 6x, I'm going to let that be equal to theta. I'm just going to take what's on the inside of the parentheses. So that means that theta is the inverse sine of 6x. Now what that means here is this: sine of some angle theta equals 6x. And I'm going to put this 6x as 6x over 1. Now I'm going to draw my right triangle. Now in this case here, let's say theta is right here. The sine, of course, is always the opposite over the hypotenuse. Now, the reason I wrote 6x over 1 is to use that in this relationship here. Sine is opposite over the hypotenuse. The opposite would be 6x, that's this side at opposite angle theta. The hypotenuse, which is the longest side, that's going to be 1. Okay, now I need to know the length of this side right here, which I'm going to call A. The Pythagorean theorem is this: a squared plus b squared is equal to c squared. A is what I'm trying to find, so that's a squared, plus b, that's this length right here, that's 6x, and that's going to be squared, is equal to c, which is 1, and that's squared. So it'd be a squared plus, what's 6x and you square it? 36x squared is equal to 1 squared, that's going to be 1. Now I need to solve for a. So to solve for a, I need to subtract 36x squared. So that means a squared is equal to 1 minus 36x squared. And then if I take the square root on both sides, and since my lengths are going to be positive, I'm not going to need that plus or minus symbol. So it'll be a is equal to just the square root of 1 minus 36x squared. Okay. Since I've already let theta be this, that means that the cosine of theta, so to find the cosine of theta, that's going to be the adjacent side over the hypotenuse. So my adjacent side is that square root of 1 minus 36x squared divided by the hypotenuse, which is 1. Well, that just end up being the square root of 1 minus 36x squared. Which means that the cosine, and I'll replace the theta with that sine, inverse sine of 6x, because that's what it was equal to. That'd be equal to this answer right here, the square root of 1 minus 36x squared. Okay. Are there any questions about problem number 9? All right, problem number 10. The function s of t represents the position of an object at time t moving along a line. Suppose s of 3 is equal to 116 and s of 6 is equal to 161. There should be an equal sign in between those two. Find the average velocity of the object over the interval of time from 3 to 6. Okay. All right, this was discussed in section 2.1. And we are told that S of 3 is equal to 116. And of course, S of 6 is equal to 161. The interval is from 3 of time would be from 3 to 6. So in this case here, this is A and that's B. In fact, the average velocity, which is this notation here, that's going to be S of B minus S of A. The whole thing is divided by B minus A. Well, of course, A is 3 and B is 6, so that means S of B is just S of 6 minus S of A will be S of 3 divided by B, which is 6, minus A, which is 3. Now, we're told what S of B is, which is, in this case, 161, minus S of 3, which is 116. Let's go ahead and do 6 minus 3, which is 3. Now, what's 161 minus 116? 45 over 3. And 45 divided by 3 is 15. And that's all there is to it. So here the average velocity of the object over the interval of time from 3 to 6 will be 15. Okay. All right, any questions about problem number 10? All right, number 11 is evaluating limits from a graph. And it says here, use the graph of h of x to find the following values if they exist. So starting with part A, we want to know what h of 5 is going to be. Okay, it's 8. Because here's 5 right here. Here's the point where at x equals 5, the corresponding y value there is going to be 8. So h of 5 will be 8. Okay. Because part A is just finding the value of h of x when x is equal to 5. Part B is finding the limit as x approaches 5.
6.
Okay. And this is of h of x. And in this case here, I think you said 6. Because to the left of, here's 5. To the left of 5 is going to 6, and to the right of 5 is also going to 6. They're both going in the left-hand limit and the right-hand limit go to the same value. So that means the limit as x approaches 5 of h of x will be 6. Now, part C, h of 7 does not exist. Because at h, at 7, we have an empty circle there. So there's no value for that. So that means h of 7 does not exist. All right. Part D, the limit as h approaches 7 of the function h of x. It'd be what, 3? Okay. Here's 7 right here. To the left of 7 is getting closer and closer to 3, and to the right of 7 is getting closer and closer to 3. Both the left and the right-hand limits approach the same value. So it'd be 3. And part E, the limit as x approaches 8 of h of x. I believe that's 4. Because at 8, at 8 it's going to be 4. Are there any questions about problem number 11? Okay, so with those, you want to make sure that the limit on the left side, the limit for that value on the right side approach the same value for h of x, or for whatever that function is. In number 12, let f of x equal to x squared minus 25 divided by x plus 5. In this case here, you're going to do two parts. You're going to calculate f of x for each value of x in the following table. Then part B, make a conjecture about the value of the limit as x approaches -5 of x squared minus 25 divided by x plus 5. So here you're given the table. Okay, so let me go ahead and generate that. So here we got x and then f of x, and then -5.1, -5.01, -5.001, and then -5.0001. And of course, at -5, we know we're going to get an error message, because at -5, we will get a 0 in the denominator. And then to the right of that is -4.9999, -4.999, and then -4.99. And then the last one would be -4.9. Okay, so what I'm going to do is just go ahead and put this in the calculator. And of course, that f of x is that, of course, that x squared minus 25 divided by x minus 5. Got to put that there as well. All right, so what I'm going to do is go to y equal to, let me clear this crap that's in this in y1. The numerator and the denominator I will put in parentheses. So the numerator will be left parentheses. For the x, you always press xt theta n for the x. Hit the x square button to square it, then minus 25, close parentheses. And then divided by, and then left parentheses for your denominator, xt theta n for the x minus 5, close parentheses. Now here's what I'm going to do. I'm going to do second and then window for the table set. You want to make sure for your independent variable, ask is highlighted. If it's not, then you use your down arrow key, right arrow key to put the cursor on top of the word ask under independent and press enter. And then go to second and graph for your table. Now what I'm going to do here is press delete to delete all this stuff under X, because I'm going to ask the calculator for what f of x is at these values here. So like for -5.1, I'll do the negative key, 5.1, hit enter. Let me put this on top. So this is going to be -0.1. Just want to make sure. And then -5.01 will be -0.1, -0.01. And then -5.001, that'd be -0.001. And then -5.0001. Let me use my up arrow key and then the right arrow. Actually, it's going to be with 4 zeros in front. I mean, 3 zeros in front. I can tell you that. Did I enter that correctly?
I have a plus sign down there.
Okay, that's why. Yeah. This will be plus. No wonder. And it says so in the problem right here, and I copied it all wrong. Okay, so that's going to change a bit. So let me do this over. Okay, that's okay. And then second table, let me delete all of this. And then that's going to change everything here. Okay. So negative 5.1. That's going to be 10.1. That's what. And then negative 5.01. That's going to be 10.001. I mean 10.01. And then negative 5.001. Let me do my up arrow, and then this will be negative 10.001. And then let me wipe this out. Negative 5.00, oops, negative 5.0001. Up arrow and then across. Negative 10.3 zeros and then a 1. No. Okay, negative, 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 negative 10 point. Okay. Now let's look to the left of negative 5. As we come in from the left of negative 5, what value are we getting closer and closer to? Negative 10. And then for the values on the right, let's see, negative 4.9999. If I look at it, it'll be negative 9.9999. And then negative 4, let's see, negative 4.999. That's going to be negative 9.999. Negative 4.99 would be negative 9.99. And then negative 4.9. That'd be negative 9.9. As we come in from the right of negative 5, the function value will be approaching where? Also negative 10. So that means here, well, that table is part A. Part B, we want to find a conjecture about the limit as x approaches negative 5 of x squared minus 25 divided by x plus 5. What do you think that's going to be? Negative 10. Because the limit on the left side of negative 5 approaches negative 10, and the limit on the right side as x approaches 5 approaches negative 10. So that's right there is problem number 12. Complete the table and then make the conjecture or conclusion about the value of that limit for that function as x approaches negative 5. All right, questions about problem number 12. Okay, problem number 13. And that's A, B, C, D, E, and F. He was just evaluating the following limits here. Using those limit laws here. And also using the rule that you can use direct substitution if that works. Or you may have to factor and divide common factors out. Or use conjugates if you get an indeterminate form of 0 over 0. In this case, for the limit as x approaches negative 2 of 7x plus 1. Well, in this case, we can just use direct substitution by just replacing the x with that negative 2. So it'll be 7 times negative 2 plus 1. And then 7 times negative 2, that's negative 14. What's negative 14 plus 1? Negative 13. That one was simple. Questions on part A. Now, part B, we got the limit as x approaches negative 6 of pi. What would that be? Pi is a special constant. What's the limit of the constant? In this case, it's going to be pi. Because pi is 3.14 and so on. So the limit of a constant is a constant. All right, part B. Part C. Limit as x approaches negative 1 of 2x cubed minus 5x squared plus 4x plus 8. And I want to find its limit. Well, this is a polynomial function that we're dealing with, so we don't have zeros in the denominator for this one. We can use direct substitution. So it'll be 2 times negative 1, and that's cubed, minus 5 times negative 1, and that's squared, plus 4 times x, which is negative 1, plus 8. So in this case here, if I cube a negative 1, it's going to be what? Negative 1 times the 2 in front would be negative 2. Negative 1 squared would be just 1 times a minus 5 would be a minus 5. 4 times negative 1 would be negative 4, and then plus 8. Now what's 2 minus 5? Negative 2 minus 5 minus 4 plus 8 equal to negative 3. So the limit as x approaches negative 1 of 2x cubed minus 5x squared plus 4x plus 8 would be negative 3. Okay. Are there any questions about part C? All right, part D is the limit as x approaches 1 of 5x squared plus 8x plus 2 divided by 7x minus 2. Now, when I replace the x with the 1, will I get a 0 in the denominator? No. So I can go ahead and use direct substitution here. So this will be 5 times 1, and that's squared, plus 8 times x, which is 1, plus 2, divided by 7 times x, which is 1, minus 2. Okay, we square the 1, that's going to be 1 times 5, that'll be 5. 8 times 1, that's 8, plus 2. 7 times 1 is 7, minus 2. What's 5 plus 8 plus 2? 15. 7 minus 2 is 15 divided by 5, 3. So the limit as x approaches 1 of 5x squared plus 8x plus 2 divided by 7x minus 2 would be 3. Okay, questions on part D? All right, part E looks like this. Here we got the limit as x approaches 4 of x squared minus 2x minus 8. The whole thing is divided by x minus 4. Now, if I do direct substitution, would I get a 0 over 0 for this?
Yeah.
Yes, we will. So that means we need to factor and probably divide out some common factors, if at all possible. Let's see if we can factor that numerator into two binomials.
Do x minus 4 and x minus 2.
Well, the x minus 4 is right, but what about x? Is it minus 2 or plus 2?
Oh, plus.
Because that minus 4x and a plus 2x will give you minus 2x as a middle term. So x squared minus 2x minus 8 factors as x minus 4 times x plus 2, and that's divided by x minus 4. Now, what can I divide out? The x minus 4s. And I will do this under here. So that means I have a limit as x approaches 4 of just x plus 2. Now we can do direct substitution here. So what's 4 plus 2? 6. So the limit as x approaches 4 of x squared minus 2x minus 8 divided by x minus 4 will be 6. Okay. Questions on part E. And finally, part F is the limit as x approaches 441 of the square root of x, then minus 21, all divided by x minus 441.
I would say x minus 2.
Well,
Multiply by the numerator.
yeah, multiply the numerator by the conjugate. Okay. I'm going to bring this over. What is the conjugate of the square root of x minus 21? Square root of x plus 21. So the numerator and the denominator will be multiplied by the square root of x plus 21. That's what we call the conjugate.
X minus 2.
You say 2? Yeah.
Mm-hmm.
I got 2.
Yeah.
So you got 2.
Mine says 2.
How is that? Because I made copies of this and, well, make it 21. Let's make it 21. Okay, because I can look. And on these copies, it's got 21 on here. Okay. So here we're going to have the limit as x approaches 441. We bring that down. That numerator, you always square the first term minus the square of the second term. So if I take the square root of x and we square it, it will be what? Just x minus the square of 21. That's going to be what? 21 squared. 441. Then that's going to be divided by x minus 441 times the square root of x plus 21. I'm not going to multiply that out because you're going to see what's going to happen here. That x minus 441, that's gone. That divides out. So I have the limit as x approaches 441, and this is going to be 1 over the square root of x plus 21. Now we can take the limit by doing direct substitution because we're not going to get a 0 in the denominator. So this will be 1 over square root of x, which is 441, plus 21. And what's the square root of 441? And 21 plus another 21 would give us 42. So it'll be 1 over 42. So the limit as x approaches 441 of the square root of x minus 21 divided by x minus 441 will be 1 over 42. Okay. Are there any questions about part F of number 13? Or are there any questions about what will be on your first exam?